Hello everybody, is the audibility fine? Am I audible to each and every one of you? Great. Am I audible? Fabulous. Is the audibility absolutely fine? Good afternoon everybody, good afternoon Deepika, Akash, Shalvi, Deepa, Deepshika. Fantastic. So the audibility is absolutely fine. Fine? Great. So the audibility is absolutely fine. So I think we should start the session. Right. So prior to this, we already had 6 classes. This is my 7th session, and I probably need 4 to 5 more sessions. We probably need 4 to 5 more sessions, and that will be it. To all those people who have attended all the sessions, great. Make sure you jot down each and every point. And to those people who haven't attended or somehow missed a few classes, those sessions are already available on the YouTube. So what you can do is, you can go through all the sessions, but do make sure that you jot down all the important points. Fine. So do make sure that you jot down all the points. So that will be very, very important, right? Great. So before starting today's session, a small line for you guys. A very, very small point for you, all of you. Whenever, whatever, for example, whatever new we are doing, many a times we actually get scared of what will going to happen, or what my friends will say. What my friends will say, or what others will say, what my family will say. Every time whenever you are scared of something, every time whenever you are scared of something new, or whenever there is a doubt, whenever there is a dilemma, whether to do something or not, ask yourself one simple question. If I were not scared, what I would have done? If there would not have been any iota of fear, what is that I would have done? What is the decision that I would have taken? And then take the decision. Do remember this, it is not the fear that breaks us. It is not the failure actually that breaks us, it is the fear of failure that breaks us. So whenever you are trying to achieve something new, whenever you are trying to do something new, whenever you are going for new adventure in your life, new expedition in your life, every time whenever you are scared of something, do ask yourself, what I would have done if there would not have been even an iota of fear inside me? What I would have done if I would not have been this scared? More often than not, you will get the correct answer, and whatever answer you are going to get will be right from your gut. And more often than not, the answers that we get from our gut are actually correct answers. Fine. Shall we start today's session? Great. So I think we should start today's class. In today's class, we'll be starting probability. So we are discussing number system second part, and that is permutation, combination and probability. In today's class, we will be discussing more of probability, right? Fine. So let's start then. There were 2 scientists, and these 2 scientists were Mr. B. Pascal and Koglomorov. The name is not important. There was one word these 2 guys have used, and that word was experiment. They've used the word experiment. And they said there are actually 2 different kinds of experiments. First, where you know the outcome. For example, all of us from engineering background, and during our very first year, we have done titration, and even our school days as well. We have actually done titration. We know that the reading comes out somewhere around 9.6, 9.7. So what we do, because we know the reading must be 9.6, So we open that funnel and immediately till 9.6, because 9.6 must be the answer. So those kind of experiments where you know the outcome, these kind of experiments are called deterministic experiments. Deterministic experiments. Whereas the experiment where you are not aware of the outcome, but you are definitely aware of the range of the outcome. For example, during the lockdown, we have definitely played Ludo, Sapsidi, these kind of games. For example, if you throw a die, you can get 1, 2, 3, 4, 5 or 6. If you throw a coin, you'll either get a head or a tail. You are not sure what you will going to get, but you are definitely sure either it will be a head or a tail. You are not sure when you throw a die what you will get, but you are sure I am going to get 1, 2, 3, 4, 5 or 6. These kind of experiments where you are not sure about the outcome, but yes, definitely you are sure about the range of the outcome. These kind of experiments are called probabilistic experiments or random experiments. These kind of experiments are called probabilistic experiments or random experiments. And that is why whenever you come across any question from probability, the language is like this: in a random experiment, and then the question starts. They start with this language because this is the kind of experiment they are actually talking about. For example, throwing a die, throwing a coin. For example, if you want to take one card from a pack of 52 cards, so you are not aware of the outcome, but you are definitely aware of the range of the outcome. Fine. So if you throw a coin or if you throw a die, this is just a trial. If you throw a die or if you throw a coin, this is just a trial. And now when we talk about the outcome, and now when we think in terms of outcome, you threw a coin, you threw a die or a coin, this is a trial. Now I am concerned about the outcome. What is this, the head or tail? Once you are concerned about the outcome, this is called an event. Now when you are concerned about the outcome, then this is called an event. And an event can be favorable or unfavorable. When can you call an event favorable? And when can you call an event unfavorable? Listen to this very, very carefully. You need to understand just a few terms. That is it. That is what the probability is all about. For example, you threw a dice. For example, you are playing snakes and ladders. You are at 99. You need just one. You threw the dice. You want one. That is favorable event. Other than that, you can have 2, 3, 4, 5, 6. These are unfavorable events. So favorable event and unfavorable event, when you add both these kind of events, you will going to get total number of cases, or the very same thing we call as sample space. The very same thing we call as sample space. Is it fine, everybody? Is it clear to all? So in very, very simple language, what probability is? This favorable event upon total number of cases. So my point is, I always insist, whenever you come across any kind of question in probability, first of all, this is what probability is: a favorable event upon sample space, or I want you people to jot every single thing, whatever I say, mark my words, you will feel the change. That is for sure. Irrespective of the fact whether this topic or even the entire aptitude segment of yours is good or not, that's not important to me. Whether you have started or you have yet to, but if you write every single thing, whatever I say, you will see a striking difference in your aptitude. This is my promise to you. So, I always insist, whenever you are doing any question from probability, start from here. Although this is it seems to be a very small point, but it is actually a very, very good point. During our school days, especially in our 9th, 10th class, when we first time we come across this topic probability, every single time whenever a question comes from probability, 1 marks is actually assigned to this part. How we are defining the event. I'm not saying to define this event in a very proper, very meticulous way, but still I want you people to define this part, because once you define the event correctly, more often than not you will get the correct answer. And then I want you people to think of this. When you think about the sample space is like a universal set, and the subset of this is actually called favorable event. And then I insist you should move to this part. So sir, what you are suggesting is this, that we should always start with event and then sample space or total cases, and then we should finally move to favorable event, right? Absolutely. Absolutely correct. This is what we should do. Is it fine, everybody? Is it clear to all? Has everybody understood every single point? Right? Although this is a very small point, but in SSC, this question was asked, the range of probability. Each one of us, we are from engineering background, so I do believe that you know this, but still, even if you know this, I want the people to jot this. The range of probability of occurrence of an event E must be less than or equals to 1 or greater than or equals to 0. So this is what P of A is. Is it fine, everybody? Is it clear to all? Is it absolutely fine? Great. Let's take a very basic question. For example, if you throw a die or dice, that is fine. If you throw a die. So the first thing is, what should be the sample space? Even before starting this question, we need to understand this. If you are throwing one single dice or die, singular of dice is die, but these days we use dice for singular and plural. That is why there is no problem. The sample space would be 6 to the power of 1. If you throw 2 dice, sample space would be 6 square. If you throw 3 dice, sample space would be 6 cube, and so on. If you throw n number of dice, this is what sample space looks like. Not just this. Listen to this once again. If you throw one single dice, the sample space would be this. Then, if you throw 2 dice, or if you throw 1 dice twice, sample space would be this. If you throw 3 dice, or if you throw 1 dice thrice, the sample space would be this. If you throw n number of dice, or if you throw one single dice n number of times, this would be sample space. Great. So the point is, whatever you are throwing, either whatever you are throwing, whenever you are trying to find the sample space, you need to see the number of faces it has got to the power of what? The quantity, the number, or number of throws. Fabulous. Sir, for example, is it equally valid in case of coin? Yes, of course. If you throw one single coin, the sample space would be 2 to the power of 1. On the contrary, if you throw 2 coins, the sample space would be 2 square. If you throw 3 coins, sample space would be 2 to the power of 3. If you throw n coins, sample space would be 2 to the power of n. And not just this. If you throw 2 coins, or if you throw 1 coin twice, If you throw 3 coins or if you throw 1 coin 3 times, if you throw n number of coins or if you throw 1 coin n number of times, this is how this thing pans out. I think this is absolutely fine. As you started this, so let's take only 1 dice. Because there is only 1 dice, therefore sample space is equals to 6. Absolutely correct. Absolutely correct. And if we are asked that, find the probability of getting an even number. So what is the probability of getting an even number? 3, 2, 4 or 6. So the numerator must be 3. So the probability would be half. On the contrary, if we are asked, no, find the probability of getting those numbers which are divisible by 3. So if you throw 1 single dice, the probability of getting those numbers which are divisible by 3 would be 3 and 6. That is, here we can have only 2 cases and thus the outcome must be 1 by 3. Whereas if we want to find the total number of, if we want to find the probability of the cases such that the probability of those numbers which are even or multiple of 3. Even or multiple of 3, yes. Probability of getting those numbers which are even plus probability of getting those numbers which are divisible by 3 minus probability of getting those numbers which are even and divisible by 3. Great. So what is the answer? This 6. Even number 3 by 6. Probability of this 2 by 6. Both these cases 1 by 6. All in all, the answer pans out to be 2 by 3. Is it fine, everybody? Is it clear to all? Is it clear to each and every one of you? Great. So this is just for 1 single dice. Nice. What happens when we throw 2 dice? Okay, let's see this. Let us suppose if we throw 2 dice, then what happens? If you throw 2 dice, if you throw 2 dice, we know that the sample space would be 6 square, that is 36. I personally don't recommend writing it like this, 1 comma 1. So you mean to say that this is incorrect? No, this is absolutely correct. There is no problem with this. But I don't prefer writing it like this. There's no need to write like this. There's no need to write like this. This is what we used to study in our school days, right? But if we are asked that, find the probability of getting what? Let us suppose if 2 dice are thrown, and if we are asked, find the probability of getting the first question. Even number as the sum, of course it means the sum of top face of the 2 dice, right? Great. So what we are aware of? We are aware of the denominator. That's 36. Then the second point is, when you are saying the sum must be even, how many cases can we have? 2 cases. How can we say that we can have 2 cases? Because what we know is even plus even is an even number. We also know that odd plus odd is also an even number. But yes, even plus odd is definitely an odd number. So what we know is this. This is the first one, this is the second one. Both the cases are equally valid. It means that, say you are saying, this is what you are saying, right? Here we can have 2, 4 or 6. That is, this can be filled in 3 ways. This is what we have done in permutation combination 2, 4, 6. This can be filled in 3 ways. Instead of counting each and every case. How many cases? 3 into 3, that is 9 case. But we can have one more case. One more kind of case. 1, 3, 5. When these 3 numbers are odd. And 1, 3, 5 when these 3 numbers are odd. 3 into 3 is also 9. Is it fine, everybody? Is it clear to all? If we throw 2 dice, find the probability of getting an even number as the sum. I am not saying to count each and every case. Instead of that, we know that even plus even is even. So this is the first case when both the dice are even. This is the second case when both the dice are odd. Nice. So either this will happen or this, and thus 9 plus 9 would be 18. Fabulous. And if 9 plus 9 is equals to 18, this is the answer. But here we can see one more thing. What is that? Here we can actually see one more thing, and that is probably more important. What is that? Here we can see that these 9 cases, let's see these 9 cases. What these 9 cases are: 2, 2, 2, 4, and 2, 6. 4, 2, 4, 4, and 4, 6. 6, 2, 6, 4, and 6, 6. Why I have written all these numbers? There is a very specific reason why I have written this. Listen to this very, very carefully. Here we can see 2, 4 is a case and 4, 2 is also a case. Similarly, we can see 2, 6 is a case and 6, 2 is also a case. Similarly, we can see that 4, 6 is a case and 6, Sir, what is the meaning of this? It means that in case of dice, you cannot neglect arrangement. Arrangement is very, very important in case of dice. Is it fine, everybody? Arrangement plays a critical part in where? In case of a dice. So, in case of dice, arrangement is important. Is it fine, everybody? Is it clear to all? So, the point is 2, 4, 4, 2. Great. 2, 6, 6, 2. 4, 6, 6, 4. So, all these are arrangements. So, arrangement is there in case of dice. Do remember this. Is it fine? Is it clear to all? Fabulous. Nice. Shall we proceed further? Yes, of course we should. Let's take one more example. Let us suppose if this case is given. I have taken the very first one. I have taken the first one. In the PDF that I have given to you, in the PDF, I want to be able to go to question number 33rd. We have discussed this one, an even number as a sum. I want you people to find this, the sum as a prime number. The sum as a prime number. Now listen to this. The point is, when you say the sum must be a prime number, how should, what should be the inception of our thought? How we should start? We should start like this. Question number 2. If you are saying that the sum must be prime, forget about this, prime and all, forget about all these things. Whether the sum is prime or not, forget about all these things. Just focus on this. What can be the minimum sum? When you throw 2 dice, what can be the minimum sum? Minimum sum would be 2. How you can have 2? 1, 1. What should be the maximum sum? 12. How you can get 12? 6, 6. Now consider this part. You want prime numbers for this. That is, now you can see that you want to find the sum as prime numbers between this, including both these numbers. So now the prime numbers will be 2, 3, 5, 7 and 11. Is it fine, everybody? 2, 3, 5, 7 and 11. Is it clear to each and every one of you? 2, 3, 5, 7, 11. So the prime numbers would be 2, 3, 5, 7, 11. Is it clear, everybody? Is it clear, everybody? This is what we are actually concerned. We should actually be concerned about. What is that we should be concerned about? 2, 3, 5, 7, 11. So when you say that the sum must be prime, the very first thing is, what should be the minimum sum? The minimum sum must be 2. What should be the maximum sum? 12. And between this, these are the numbers. 2, 3, 5, 7 and 11. Absolutely. Is it fine? How we can form a 2? 2, 1, 1. That is it. How we can have a 3, 1, 2, a 5, 1, 4 or 2, 3. Nice. And then what is that we are left with? 7, 1, 6, 2, 5 and 3, 4 and finally 11, 5, 6. Can we have any more case other than this? No. Sir, but we can have one more case. Instead of writing 1, 2, I may write 2, 1. Of course. Sir, instead of writing 1, 4, I may write 4, 1. Yes. Instead of writing 2, 3, I may write 3, 2, 1, 6, 6, 1, 2, 5, 5, 2, 3, 4, 4, 3, 5, 6. And yes, of course you can write. But why you want to write? That is more important. Why you want to write, sir? What does that mean? Instead of writing all the cases, we can write 2 factorial. That is what we've discussed. That is what we have discussed in permutation combination. 2 factorial. It means 1, 2, 3, 4, 5, 6, 7. 7 into 2 would be 14 plus 1, 15. Is it fine, everybody? So, all in all, this is 15 upon 36, 5 upon 12. Is it clear to each and everyone? Is it fine? Is it fine, everybody? Is it clear to each and everyone? Nice. So this was a good point actually. Put up a single star on this. Put up a single star on this. It's a very important question for your GATE exam. Right? Fine. Is it clear to each and every one of you? The sum must be a prime number. So what kind of prime number? 2, 3, 5, 7, 11. So these are the numbers we can form. Next, there was one more question actually. And what the question was? This was the question. The sum must be, listen to this. What we'll do is we'll break it into 3 parts. In question number 33rd, specifically I have given a very specific thing. And what is that? The sum must be at least 10. Let's do one thing. Let's break this question into 3 parts actually. What will going to happen if the question is sum at least 10, at most 10 and exactly 10. We'll solve all these 3 questions. If the sum is at least 10, first of all, what is the meaning of this? When you say the sum must be at least 10, the meaning of this would be sum must be greater than or equals to 10. In probability, inequality is actually very, very important. Why inequality is very, very important? Because of this reason. Every time whenever you see inequality, break it into pieces. For example, here we can bifurcate it. Sum can be equal to 10 or it can be greater than 10. But at the very same time, you should understand that when you are saying it should be greater than 10, what are the cases we can have? The maximum benefit I can avail is this. So all in all, what I can understood from this, here we can have 3 cases. When the sum is 10, when the sum is 11, when the sum is 12. Either this or second or the third one. That's it. Is it fine, everybody? Is it clear to all? Here we can see we can have 3 cases. What these 3 cases are? Sum equals to 10. sum greater than 10 that is equals to 11 or equals to 12. I think this is clear to each and every one of you. Is it fine? Is it clear? Nice. Fabulous. So this is absolutely clear, right? Nice. So when you say sum must be equals to 10, equals to 10, what is the meaning of this? It means 4, 6 and 5, 5. That's it. When you say equals to 11, it means 5, 6. When you say it must be equals to 6 and 12, 6, 6, that's it. Don't forget the arrangement. When you are writing 4, 6, here we should have 2 factorial cases. When you write 5, 6, here we should have 2 factorial cases. So 2 plus 2, 4 plus 1 plus 1. I think this is good enough. 4, 6 is 10, 5, 5 is 10. 5, 6 is 11 and 6, 6. All in all, how many cases do we have? We've got 6 cases, divide by 36. So 1 by 6 is the answer. Is it fine, everybody? Is it clear to each and every one of you? Is it fine? Great. So you said other than this there is something else which is also important. Yes. The question which I have given was categorically sum at least 10. If this question would have been sum exactly 10. Exactly 10. So what is the meaning of this? The meaning of this is sum equals to 10, that's it. So what do you say? What will the probability of this? When you say the sum must be equals to 10, in that case, when you say the sum must be equals to 10, in that case, the answer must be 4, 6 or 5, 5. Don't forget the arrangement part. That is 2 factorial for this. All in all, 3 upon 36, that is 1 upon 12. Right? I think this is good enough. And finally, the last one. And what is the last one? If the sum is at most 10. What is the meaning of this? Even before solving this, we should write it in the form of inequality. It means the sum must be, what should be the minimum sum? 2, 3, 4, 5, 6, 7, 8, 9 and 10, which is actually, here we can see that too many cases, and that is why we can solve it like this. The sum must be probability of getting those cases where the sum is greater than 10. I think this is good enough. Is it fine, everybody? Is it clear to all? Is it clear to each and every one of you? Right? So greater than 10, what is the meaning of this? It only means that the sum can be 11 or the sum can be equals to 12. That is it. If the sum can be equals to 11, 5, 6, this is 6, 6. Nice. And if this is the case, 2 factorial for this case. And there is only one case over here. So all in all, here we can have 1 minus 3 by 36, 1 minus 1 by 12, 1 11 by 12. Is it clear, buddy? Is it clear to each and every one of you? I think this is absolutely clear now, right? Great. This must be clear to each and every one of you. Fine, absolutely correct, right? Fine. Let's take one more example. Let us suppose, I'll take only one example now. One part of this example. I have given a question in a book. If you want, you can check the PDF, the one that I have already provided you guys. You can check the question number 34th. We will not discuss all these 3 questions. We will take only one of them, because now we have understood. We have understood this. Let us suppose if we were supposed to find what? If we are supposed to find the the sum must be at least 6. If this would have been the case, because we are throwing 3 dice, so sample space must be 6 cube, that is 216. Fabulous. Fabulous. And because you are throwing 3 dice, and it has been mentioned that sum must be at least 6. What is the meaning of this? The sum can be 6, 7, 8, 9, 10, 17, 18. So instead of solving this, what we can do? We can see 1 minus probability of getting sum less than 6. When you write sum must be less than 6, here we can have 3 cases. Minimum sum would be 3, then 4, and then finally 5. Fabulous. So when you say sum must be less than 6, it means here we can have 3 cases. Sum can be 3, 4 or 5. That is it. I think this is good enough now. I think this is absolutely fine. So the sum can be 1, 1, 1. This is 1, 1, 2, and here it is 1, 1, 3, and 1, 2, 2. Sir, but won't there be an arrangement? Of course there will be some arrangements in these 3 cases, but there is no point writing those arrangements. You can straight away write it like this. That is why we have discussed permutation combination. So 3 into 3 cases, that is 9. 9 plus 1 is 10. And therefore, this is 1 minus 10 upon 216. So the answer must be 206 upon 216. That is 103 upon 108. Is it fine, everybody? Is it clear to each and every one of you? Is it clear? Fine, great. I've already discussed the first part, and I expect that you are in this position to complete the next 2 parts. So the next 2 parts are assignments, so you should try this part. The sum at most 6 and exactly 6. Is it fine, everybody? Is it clear to each and every one of you? Whatever we have discussed so far, is it clear? Nice. Let's take one question which actually came in your exam. So what was the question? This was the question. Where is that? To this. Question number 36. This is the one which came in your exam. This is the question which came in your exam. Question number 36. Go ahead, mark the answer. Question number 36. I want the answer in this case. What is the answer? Well done. Make it fast, everybody, make it fast. I think we are in this position to mark the answer of this question. So, how many dice are there? We can clearly see there are 2 dice. And if there are 2 dice, one thing is for sure, the sample space would be 6 square, that is 36. What is that we are searching for? The probability that the product of the numbers appearing in the top face of the 2 dice must be a perfect square. Probability of getting a perfect square. Instead of randomly trying to find the answer, think of this. When you are throwing 2 dice, and when you multiply the top face of the 2 dice, what kind of squares you can have? 1, 4, 9, 16. Then there is 25 and 36. How you are going to get all these numbers? You get 1 by 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5, and then 6 comma 6. There is one more case, and what is that? Absolutely. Absolutely. In case of 4, you can form 4 like this as well. 1 comma 4, 4 comma 1. That is the arrangement in this case, 2 factorial. So how many cases? 1, 2, 3, 4, 5, 6, and then these 2 more cases. Is it fine, everybody? So here what we can see, although it seems as if first is the correct answer, but here in this case we can clearly see that. Anything else? If there is any doubt, anything else? 1 can only form like this. 1 can only be formed like this. 4, we can have a 4 like this. 2 comma 2 and 1 comma 4. 1 4 4 1. 9, other than 3 comma 3, there is no other way to form a 9. 16, either you can take 4 comma 4 or 1 comma 16, but 1 comma 16 is not available. Similarly in this case as well. So the point was 6 cases here and 2 cases here, 2 factorial. So this is 8 upon 36. That is 2 upon 9. Is it fine, everybody? Is it clear to all? I think it is absolutely clear to each and every one of you. Then there is one more very specific, very simple question that used to come. For example, for the range of 1 to 50, both included, of course, both included. For the range of 1 to 50, if we are to select just one number, so what is the sample space? The sample space would be 50C1, that is 50. If we are to find probability of those numbers, which are what? Natural numbers. So that is it, natural numbers. Yes. Second, prime numbers. If we are to find probability of those numbers which are composite numbers, for the range of 1 to 50, probability of getting these things. Next, similarly, perfect square. Find the answers. Perfect squares. Next, probability of finding perfect integer. Try to find answer of all these questions. And perfect integers. If you want to find all these answers, from 1 to 50, all these numbers are natural numbers. So 50 upon 50, anyways the probability would be 1, whichever number you select. Prime number, I have told this earlier as well, I think you should remember, for the range of 1 to 100, total number of prime numbers are 25. Competitive exams do consider that you have an idea of this. 1 to 75, total number of prime numbers are 21. 1 to 50, total number of prime numbers are 15. And 1 to 25, total number of prime numbers are 0, 9. Don't forget this. This is very, very important. I want you people to jot this absolutely clearly. Is it fine, everybody? Is it fine? Do we know the meaning of this word insipid? INSIPID. Anyone who knows the meaning of this word insipid? Anyone who knows the meaning of this word insipid? Anyone who has got any idea what the meaning of this word is? Insipid? Yes, correct. Insipid is listlessness. Absolutely no energy. Right now you guys are this. Absolutely no energy. And what is the reason? Why there is absolutely no energy? This is listlessness. Absolute listless. No energy. It's up to you, it's your call. But if you want to study like this, I think much better option should be you can log out and you can go for you can take a small nap. That's a much better answer. That would be probably a better strategy. Whatever you do, do it decisively. If you are studying, then focus 100% on studies. And if you don't want to study, just go and sleep. Take a small nap. So that when you can come back, you can have some energy. Right? Yeah, let's come back to this. I don't take classes just for the sake of taking classes. That's not the point. If this would have been the reason, I would have given it the recorded sessions, right? I don't take class just for the sake of coming. I don't come at this time just for the sake of coming. There's a bigger reason. I strongly believe that we can create revolution. But not like this. Fine. But it is your call. Of course, this is your call. So, these are the total number of prime numbers for this range, right? From 1 to 100, these are the prime numbers 25, 1 to 75, 21, 1 to 50, 15 and 1 to 25, there are only 9 prime numbers. Do remember this, you will be asked regarding the very same thing. It's very, very important, right? Let's come back to this. Fine, so we were asked to find the prime numbers. So, how many numbers are there total? Total, all in all, we've got 50 numbers. And for this particular range, how many prime numbers do we have? The total number of prime numbers we have for this range is 15. And that is why the answer must be 3 by what? 3 by 10. Total number of composite numbers. How many composite numbers we can have? For the range of 1 to 50, what do you think? What do you think? No, that's not correct. That is not correct. For the range of 1 to 200, total number of prime numbers are this, but that is not required in your exam. This kind of things these kind of things you may come across, but in a very specific exams like CAT, ZAT and GMAT, not in your exam. It's a very rare chance like these kind of things you come across in your exam, right? Total number of prime numbers for the range of 1 to 200 is 46. Let's come back to this. Composite number. So, we know that for 1 to 50, from 1 to 50 there are total 50 numbers. Out of these 50 numbers, 15 are prime numbers, that is also fine. So, is it 35? No. Why? We need to subtract this 1 as well, because 1 is neither prime nor composite, and that is why this must be 34, and therefore the answer must be 34 upon 5050. 34 upon 50. Is it fine, everybody? Is it clear to all? For the range of 1 to 50, total number of composite numbers would be, other than 1 to 15, 15 prime numbers are there, and then there is 1. 1 is neither prime nor composite. So, all in all, 50 minus 15 minus 1. Great. Let's move on to the next one. The next one is very important, especially from your exam's perspective. If you say not this one, the perfect integer, this one. Perfect square is fine, that is easy as well. If you want to find those numbers which are perfect squares, this I think is a cakewalk. If you want to find the probability of those numbers which are perfect square, this is not that difficult a thing. So this is, what is the answer? 50. Fine? Is it fine? And then perfect square 1, 4, 9, 16, 25, 36 and 4, 9, 49. That is still 7 square, right? Is it fine, everybody? Then the last question I have given was perfect integer. Now what is that? Perfect integer. What is a perfect integer? First we need to understand what is a perfect integer. So this is what a perfect integer looks like. 6 is a perfect integer. And why 6 is a perfect integer? The next perfect integer is 28. But why is it so? Other than the number itself. For example, when you're talking about 6, other than 6, if you add the rest of the factors, you will get the same number. It means if you add 1 plus 2 plus 3, you will get 6, absolutely. Other than the number itself, if you add the rest of the factors, you will get the very same number. Is it fine? So 1 plus 2 plus 4 plus 7 plus 28 is 28. Is it clear, everybody? Is it fine, everybody? Right? So there is only one single digit perfect integer, and what is that? 6. There is only one 2-digit perfect integer, and that is 28. There is only one single 3-digit perfect integer that you need to find. You have to find, right? 1, 2, 3. There is only one. There is only one 4-digit there is only one 4-digit perfect integer that you need to find, right? So my point is, if you want to find perfect integer, in that case, total number of cases would be 6 and 28. That is, this denominator would be 50 and here it is 20. So 1 by 25 would be the answer. Is it fine, everybody? Is it clear to all? Right? So the perfect integer, there is only one single digit perfect integer, and that is 6. There is only one 2-digit perfect integer, that is 28. You are to find, there is only one 3-digit perfect integer that you have to find. There is only one 4-digit perfect integer that also you have to find. I think this is good enough. Is it fine, everybody? Is it clear to all? This is what was asked in your GATE exam. This is the exact question which was asked in your exam. Where is that? This. This is what they have asked. I want you people to find the answer for question number 35th. To all those people who have the PDF, please solve this question number 35th. And to those who don't have the PDF, they can download it from our Telegram channel, GATE Academy Global Telegram channel, and Saurabh Sir Official, either of the two, whichever you want. Yeah. Find the answer of this. So the last one, perfect integer, was a very important question. I want you people to find the answer of this. Very nice question, very simple question. You should find the answer of this. Very good, absolutely. So out of all 2-digit integers, okay, between this, so first 2-digit integers, how many 2-digit integers are there? For this range, the sample space would be 90. Now what is that they want? Out of all these numbers, not divisible by 7. So this is what we are looking for. We want to find those numbers which are not divisible by 7. Let's straight away find those numbers which are divisible by 7. That's it. That is it. That will be a lot easier. So till 114, 7 to 14 is 98. But the one multiple which is actually not divisible will be 7. You can see 7, 14, 21, 28, 35, 42, 49, 56, 63, 70, 77, 84, 91 and 98. Out of all these numbers, if you see, there is one number that you can reject, and that is this. Why you can reject this? Because you want a 2-digit number. So although there are 14 multiples, but you can reject one of them, and that is 7. So how many numbers are we left with? We are left with this. So 1 minus 13 by 90 would be 77 by 90. Is it fine, everybody? Is it clear to each and every one of you? Is it fine? Is it fine? Right? So those numbers which are divisible by, great, well done. Nice. Many a times, this is how they ask. For example, let us suppose, you have just randomly 1, 2, 3. These are the 3 digits you have. Okay. Let us suppose you have a few more digits. Let us suppose 4, 5, 6 and 7. Great. And then you have been told that you have to select 2 numbers. But what is the case? You have to select one number from this set A and one number from B. So that is not a problem. If you want to select one number, 1, 2, 3, 3C1 for A and 4C1 for B. So what is the condition? What is the condition that we should meet? This is the condition. The sum must be equals to 8. Now this is a good condition. The sum must be equals to 8. So we are to select exactly one number from set A, one number from set B, such that the sum must be equals to 8. So first of all, how many cases can we have? Listen to this very carefully. 1 plus 7 is 8, yes. Then 2 plus 6 is also 8, yes. Then 3 plus 5 is 8, yes. Listen to this very, very carefully. So how many cases can we have? Here we can clearly see that we've got 3 cases. So you mean to say, sir, 3C1? Yes, of course. So the answer would be 1 by 4. It might be possible you've understood this, but later on, when you take a cursory look of this, you may come across certain kinds of very specific doubt. And what those doubts may probably look like this. Sir, I have a doubt. Here you selected one number from A, right? Of course. Here you selected one number from B, right? Absolutely. But here you selected only one number. So how can this be sample space? And how can this be an event? No, this one does not mean I am selecting one number. This one actually means I am selecting one single case. And this includes these 3 cases available, and each single case actually has got 2 numbers. 3C1, this is the first case, second case and third case. So out of these 3 cases, we may select any one of them. Second doubt. Sir, instead of this, if I am solving it like this, actually now I cannot able to understand what to write. Like, what you've written? Sir, I have written this. Listen to this very carefully. Sir, 3C1, is it correct? Of course it is correct. Sir, what this 3 signifies? 1, 1, 1. This is what I am assuming, right? Yes, sir, I have written for the very same reason. But after this, I cannot able to understand what to write. Am I supposed to write 4C1? No. No. But why? You have told that 3C1 is absolutely correct. Yes, indeed it is correct. Indeed it is correct. You can take any one of them. But the problem is, if you select 3C1 is fine, but if one gets selected, then there is only one case which can actually produce 8 with this one. And that specific case is 7. This is exactly the very same concept. A particular official member. Do we remember this? This is what we've discussed from jersey number. Jersey number 1, jersey number 2, jersey number 3. So just like that, for this 1, this 7 must get selected. For this 2, this, where is that? This 6 must get selected. For this 3, this 5 must get selected. That is why instead of writing this 1, you have to write for 1C1. Now this makes sense. I think this is clear. Is it fine, everybody? Is it clear to all? Is it clear to each and every one of you? Great. So either we can take it like this 3C1, but in this case this one actually represents these three cases. This one represents one selection of one case out of these three cases available, or if you want to, you may write it like this, but after that you should write 1C1. It's not the value, it is what that value conveys that is more important. I think this is clear. In your GATE exam, they've asked exactly the very same question. This is what they have asked. This is what they have actually asked. All those people who have got the PDF, I want you people to solve question number 37. To those people who have got the PDF, I want you people to solve question number 37. This is the 37th question. I don't think it is that difficult a question. We can definitely solve this. What is the answer of this question? Well done. Nice. Great. And these are the numbers, and this is what you have to do. So a set A has got numbers like 2, 3, 4, 5. Set B has got numbers like 11, 12, 13, 14 and 15. So what should be the sample space? 4C1 into 5C1. And then what do you want? The sum must be equals to 16. So how many cases we can have? With 2, it has to be 14. So the point is 2 plus 14, yes. 3 plus 13, yes. Then 4 plus 12, yes. And 5 plus 11, yes. So how many cases? Here we can have 4 cases. And that is why 1 by 5, that is 0.2. I think this is fair enough. Is it fine, everybody? Is it clear to all? Is it clear to each and every one of you? Nice, well done. I do believe that it is absolutely clear, right? Nice. Let's move on to the next one. For example, if I have written 1, 2, 3, 4, 5. How many numbers I have written on this board? Of course, I have written 5 numbers. What these numbers are? 1, 2, 3, 4, 5. Right. Absolutely. Absolutely. If I cut 2, 3. Now, how many numbers am I left with? I am left with 1, 4 and 5. That is 3 numbers. Yeah, that's not a problem. If I cut a few more numbers, then how many numbers am I left with? 1 by 5, of course. Similarly, if I write 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's take 0 as well. How many numbers are there? Of course 10. Of course 10. And if I cut 0, 4, 6, 1. What is that I am left with? I am left with 6 numbers. If I cut a few more, 2, 3, 5. I am left with 3 by 10. Sir, what does that mean? Whatever I meant, I have already conveyed the idea. Sir, how come? I want you people to read question number 38. Just go through the question number 38. And especially I am talking to those people who have the booklet, who have the PDF. And to those who don't have, see this question. What do you say? What is the answer? The probability that a k-digit, who cares man, k-digit number. Let's take a single digit number. A k-digit number does not contain this. A single digit number does not contain this. How many single digit numbers do we have? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So how many numbers do we have? We've got 10 numbers. And how many numbers you don't want? Does not contain 5, 0, 5 and the 9. How many that I am left with? I am left with 7 more numbers. So when you put k equals to 1, just check the option, which option satisfies. Sir, I can solve the very same question by putting k equals to 2. Of course you can. That's not a problem. Sir, I can, if I want, I can put k equal to 3. If you want, you can put k equal to 100. But you have to solve this, right? Absolutely correct. I think this is fair enough. Fine, great. Is everything, whatever we've discussed so far, is it clear, everybody? Is it clear to each and every one of you? I do believe that it is absolutely clear. Right? Great. Well done. In a leap year, we know that in a leap year, what we know? A leap year comprises of 366 days. Right? A leap year comprises of 366 days. So what? 366 days, it means if I divide this by 7, what I'm going to get? 52 weeks. Great. And 2 days. 52 weeks and 2 days. Sir, but what these 2 days are? Who knows, man? These 2 days can be anything. Anything it means? January, February. How can you name a day as January, February? These 2 days can be Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, Saturday, Sunday, and Sunday, Monday. Absolutely. In a leap year, total number of days are 366. And if we divide the 366 days by 7, we can categorically see that there are 52 weeks. 52 weeks means, what is the meaning of this? 52 weeks means we've got 52 Sundays, 52 Mondays, 52 Wednesday, 52 Thursday, Friday, Saturday, Sunday, everything. And what is the meaning of these 2 days? These 2 days can be any 2 days out of these days. The last 2 days can be Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, Saturday, Sunday, Sunday, Monday. So how many options we can have? There are total 7 options. And if we are actually asked, find the probability of getting 53 Sundays. So we can clearly see that there are total 7 cases. Sir, from where this 7 came? 1, 2, 3, 4, 5, 6 and 7. Great. And how you can have 53 Sundays? We can have 53 Sundays if the last 2 days are Saturday, Sunday or Sunday, Monday. Other than this, there is no chance. That is Saturday, Sunday or Sunday, Monday. So what does that mean? 2 by 7. That's it. And then, sir, then it is done. But let us suppose if we are asked, we know that this 366 divided by 7 will fetch us 52 weeks and 2 days, right? This is what I have written in the previous slide as well. And these 2 days can be anything. Anything, there is a limitation of anything. Anything, it means Sunday, Monday, Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, and finally Saturday, Sunday. Let us suppose if we are asked to find the probability of getting 53 Sundays and 53 Mondays. This is just a cakewalk. You need to count this, that's it. We know that there are 7 possibilities. When we can have 53 Sundays, 53 Sundays. 53 Sundays are this and this. First and 7th case. But at the same time, we are also searching for 53 Mondays as well. So here we can have, this won't be the answer, this is the only case. That's it. Is it fine, everybody? Is it fine, everybody? Is it clear to all? Is it fine? Great. The next one. If we are asked the probability of getting 52, let's take 52 Sundays. When you say 52 Sundays, it means, what is the meaning of this? At least or exactly? Absolutely nothing. The moment you say 52 Sundays, it only means exactly 52. So, sir, the answer must be 1. No, definitely not. Sir, why? Because when you say the Sundays must be 52, it means you have to reject these 2 cases. And why we have to reject the 2 cases? Because in those cases, Sundays would be 53, and that is not what we are searching for. And that is why the answer must be 5 by 7. These are the 5 cases, 1, 2, 3, 4, 5. And this, I believe, is probably a more important question than finding 53 Sundays. Is it fine, everybody? Is it clear to all? Is it absolutely fine? Fine, great. Let's move on and take one more. Probability of getting Sundays, let us suppose 52 and what? Mondays 53. So we know the denominator part, which is 7. What is that we are looking for? Sunday is 52 and Monday 53. Okay, fine. Let's see the Monday 53. It means the first case and the second case. Sunday, Monday and Monday, Tuesday. But at the same time, we are also looking for this part as well. Sunday must also be 52. Okay. And therefore, we have to reject the first one. This is what we are left with. Is it fine, everybody? Is it clear to all? I think this is absolutely clear now. Right? Fine? There's one small assignment. I want you people to solve this. Which part? I want you people to solve a very specific question. You can post it later on. 4. 5. Probability of getting 53 Sundays and 53 Tuesdays. 6th. Probability of getting 52 Sundays and 53 Tuesdays. And finally the last one. And finally the last one, probability of getting 52 Sundays and 52 Tuesdays. You may post all these answers later on. 1, 2, 3. I think you've understood this. Is it fine, everybody? Is it fine, everybody? Is it clear to each and every one of you? Great. I think this is absolutely fine. Right? Nice. There was one very basic question which was asked in your GATE exam, and this was the question. This is the one which was asked in your exam. To those people who have got the PDF, they can straight away move to question number 41. And to those people who don't have the PDF, they can solve this. Okay. Question number 41, everybody, make it fast, please. Don't miss this. Question number 41. Don't miss this. Let's see. There are 3 red color socks, there are 4 green color socks and 3 blue color socks. Okay. And we want to choose exactly 2 socks. It's fine. So how many do we have? 4, 3, 7 and 3, 10. That is why 10C2. But we want same color socks. And because we are looking for same color socks. Thus, what is this? 3. 3C2. This is when both the socks are of red color. And then 4C2 when both the socks are green colored socks. And then 3C2 when both are blue colored socks. I think this is good enough. So what is the answer? 45, this is 3, this is 6 plus 3. So 3 plus 3, this is 12 upon 45. Is it fine, everybody? Is it clear to all? Whatever is there in the option, please mark it. Yes. I think it is absolutely clear. Right? Yes, it is. Indeed, it is clear. Shall I proceed? Yes, I think we should. If you remember, while we were discussing permutation combination, I've mentioned a very specific thing. And what was that? Whenever you've got choice, when you want to select 2 girls or 3 boys, 2 this black color marker or 4 red color marker, whenever you've got choice, in all those cases we may use or plus, and in case of probability we say union. Whereas where there is no choice, when you want to select 2 girls and 3 boys, when you want to select 3 red color marker and 4 blue colored marker, then we use multiplication and intersection. In probability we call it intersection. Do we remember this? This is what we've written. Yes, absolutely. Absolutely. Borrowing what we've discussed over here, that is how an independent event looks like. Sir, what does that mean? Probability of A intersection B, because the 2 events are absolutely independent, we say P of A multiplied with P of B. But this we know from long back. This is something we know from long back. And in probability, this is what is called independent event. When the 2 events are absolutely independent of each other. For example, if you want to throw a die, if you threw a die and you want, let's suppose 2, and then from a pack of 52 cards you want to find an ace. These are 2 absolutely independent events. So probability of getting A intersection B would be, as these 2 events are independent, so forget about it, A and B. Great. Let us suppose if I give a question to A. Let us suppose if I give a question to A, and the probability that this guy may solve the question is 1 by 2. Let us suppose, for an example. And the probability, and B can solve the very same question, and the probability that B may solve the very same question is 1 by 3. Great. The probability that A may not solve the question would be this. And similarly, in case of B, B may not be able to solve the question. And if we are, and you know what, I personally don't like writing it like this. I directly prefer writing it like this, like A, B. Instead of writing this time and again, we will prefer writing like this, A bar and B bar, right? And if we are asked that, what is the probability that the question must get solved? It means, irrespective of the fact who is solving the question must get solved. Either A solves the question, forget about B. Either B solves the question, forget about A. Or both these guys may solve the question. Fabulous. Or if you want, you can directly write it like this. 1 minus A could not able to solve the question, and at the very same time B also could not able to solve the question. So from where actually we can write this and this? Just we need at least 2 to 3 minutes to understand this. Let us suppose if this is a circle, right? If I give a question to A, the chances that A will solve the question, whatever the chances will come inside this. right? And if A cannot able to solve the question, that will be complement of A. Similarly for B as well. If this circle represents that B may solve the question. Let's take this. This is A, B, X and N. What this A stands for? This A is, let me write it like this, A, B. So this A represents, the small a represents only A solves the question. So when you say this is small a, what actually you mean? This is what I mean. This B represents only B could able to solve the question. Sir, when you write B, what actually you mean? This is what I mean. Listen to this very, very carefully. Fine. X represents when both these guys can able to solve the question. A and B. It means this is what I mean. And there is only one place where both these guys could not able to solve. So when you say that the question must be solved, it means irrespective of the fact where this comes, this has to be, this must be part of this. Then only we may say that the question will be solved. Is it fine, everybody? So when we say that, yes, absolutely, a plus b plus 6, yes, a plus b plus x. So when we say that the question must be solved, so when we say that the question must be solved, and then when we say that either only A solves the question, only A solves the question, or only B, or A and B, now you can have a look at it. This is small a, this is small b, and this is small x. And when we say that for the very same thing, we may write 1 minus neither of the two guys could able to solve the question. This is what we mean. Is it fine, everybody? Is it clear to all? Is it clear to each and every one of you? Fine, absolutely fine. Right? And you should draw this. This is actually very important. I do believe that you should draw this. I think this is clear now. So, in this particular case, I was discussing A solves the question must be solved. That's fine. 1 minus neither of the two guys could able to solve the question, and that is why the answer must be 2 by 3. If we are asked that no, exactly one of them could able to solve the question, so this is the only way. What is this? A could able to solve but B could not able to solve, or A could not able to solve, only B could able to solve, and therefore 3 by 6, that is half. I think this is good enough. Is it fine, everybody? Is it clear to all? Right? In your exam, what they've asked, this is what they have asked. This is what they have asked. To those people who have got the PDF, please move on to question number 43rd. This is what they have asked. I do believe that this is a cakewalk. We should be in this position to solve this. Great, well done. Nice. Very good. Rest of the people, please make it fast. So here what has been asked? There are two guys, Ram and Ramesh. There are two guys, Ram and Ramesh. The probability that Ram gets selected is 1 by 6, and the probability that Ramesh gets selected is 1 by 8. The probability that only one of them gets selected. What is the meaning of this? Only Ram must get selected, or only Ramesh must get selected. Ram got selected and Ramesh could not able to make it through, or only Ram got selected, only Ramesh got selected and Ram could not able to make it through. So if this guy, if Ram got selected, 1 by 6, if Ramesh could, excuse me, if Ramesh could not able to make it, 7 by 8. If Ram could not able to make it, 5 by 6, and in this case it is 1 by 8. So all in all, what is the answer? 12 by 48, 1 by. I think this is absolutely fine. Is it clear to each and every one of you? Is it fine, everybody? Absolutely. Right? Sir, what will going to happen if we've got 3 people? What does that mean? Sir, let us suppose if we have 3 guys. What do you say? Probability that A can solve a question is 1 by 2. Probability that B may. I have given the question. I have actually given the question. Yes. I think we are in this position to solve this. To those people who have got the PDF, question number 42 I am talking about. Find the answer. Go ahead, find the answer. What is the answer? What do you say? The probability that the problem must be solved. That is it. The problem must be solved. That is what is important. Irrespective of the fact who solves the problem. So this is 1 minus A could not be able to solve, B could not be able to solve, and so it is with C. 1 by 2, what is this? 3 by 4 and no, 2 by 3. 2 by 3 and this is the last one is 3 by 4. So what is the answer? 3 by. This is the probability the question must get solved. Is it fine, everybody? Is it clear to all? Is it clear to each and every one of you? Well done. Absolutely. Right? Nice. Well done. Great. If let us suppose there is an island. It's a very beautiful island. Extremely exotic. Extremely exotic island. But unfortunately, because of high tide, you may see frequent flood. Right? Because of high tide, you may see frequent flood. What is the probability of this flood? The probability is 0.2. The probability of flood in this region is 0.2. So what does that mean? 0.2 means 2 upon 10. It means 1 upon 5. How am I supposed to read this? When Indian Meteorological Department says that there is a high probability of heavy rainfall. Do you know what is heavy rainfall? And actually what happens? Indian Meteorological Department, and then there are some private enterprises as well, like what is the name? The name of this private body is, there is some private body as well, very famous. But Indian Meteorological Department, what they do? They take last 50-year average. First of all, what is a monsoon season? When you say it's a monsoon season, it means in India, monsoon is June, July, August, September. Right? June, July, August, September. So what they do is, they take 50 years, they take last 50 years rainfall, and based on that they find the average, and that is called LPA, long period average. And any rainfall which is between plus 10% and minus 10% of LPA is called normal monsoon. If it is more than plus 10%, then it is excessive rainfall, and if it is less than minus 10%, it is deficit rainfall. And then comes El Nino and La Nino. So El Nino and La Nina. El Nino and La Nina. I want you people to find meaning of both these words, and you can post it later on. El Nino, what is El Nino and what is La Nina? In many competitive exams, you may come across these kind of words, right? So fine. I was discussing this. So what is the meaning of this? When you say the probability of flood is 0.2, it means 2 by 10, that is 1 by 5. It means on an average, you may see a flood. You may see a flood in 5 years. On an average, in every 5 years, you may see a flood. So the difference between two consecutive floods on an average is 5 years. Is it fine, everybody? Is it fine, everybody? So this is what it means. And that is exactly what they've asked in your exam. This is what GATE has asked. So this is what IIT has asked to you guys. Let's see whether you can give the answer or not. I want you people to solve question number 44. I want you people to solve question number 44. Absolute cakewalk. Great. So what is given? In any given year, the probability of the earthquake greater than magnitude 6, so greater than magnitude 6 at tear, in the general Himalayas is 0.04. That's fine. That's unfortunate, but what is the meaning of this? You may expect what? An earthquake in 25 years. On an average, you may expect. So, what is the successive? What is the average time? This is the average time. This is the average time between two successive earthquakes. What is that? 25 years. That's it. Is it fine, everybody? Is it clear to all? Is it clear to each and every one of you? Yes, of course. Of course, it is clear. Is it fine? Yes, indeed, it is fine. Right? Great. I want you people, let's take one more case. For example, if you throw two dice, what do you think? What should be the sample space? Very easy, 6 square. So sample space would be 6 square, that it means 36. If you throw two dice, the sample space would be 6 square, that is 36. But if the event is like this, sir, what is this? When you throw the dice for the second time, the value must be greater, always greater than the first throw. This is a very, very easy question. Whenever you come across these kind of questions, and that too with one single inequality, it's very easy. How come it's very easy? For example, in the first case, if you have 1, so in the second dice, what are the permissible cases? 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. How many cases? 5 cases. Let us suppose here if you have 2, 3, 2, 6, that is 4 cases. Here if you have, here if you have 3, in that case 4, 5, 6, great. 4, 5, 6, that is 3 cases. If you have a 4, 5, 6, that is 2 cases, and if you have a 5, Only one case 6. Is it fine, everybody? Is it clear to all? Is it clear to each and every one of you? This? Yes, of course. From my side, this is important to your GATE exam. If we throw 2 dice, what is the probability of getting a greater number every second time? In that case, this will be the answer. So, how many cases? Here total number of cases are 5 plus 4 plus 3 plus 2 plus 1, that is 15. No, it's not 5 factorial. To write factorial, you need to multiply, and to multiply you need AND. Either this will happen or this or this or this or this, and that is why not factorial, plus. So, total 15 cases we can have. All in all, what should be the answer? The answer must be this: 15 upon 36, that is 5/12. This is absolutely correct. Is it fine, everybody? Is it clear to all? Is it clear to each and every one of you? Right? Great, well done. Absolutely correct. Fine? Right? So what should the answer be? The answer must be 5/12. I want you people to write a very small note. What this note is, see what happens whenever you form any a triangle. This is vertex A, this is vertex B, and this is vertex C. Exactly right in front of A, we represent side small a. Usually we represent side in the form of small letters and angles in the form of capital letters. Right in front of capital B, the side can be named as B, and right in front of capital C, we may write C. Right? In case of a triangle, the very first thing we need to understand, the sum of 3 angles is equals to 180 degrees. That each one of us know. But there is something else that we should know, we should be aware of, and that is the second point. The sum of any 2 sides of the triangle, any 2, it means any 2, must always be greater than the third side. And not just this, there is one more thing. And what is that? The difference between any 2 sides of the triangle must be less than the third side. And the difference between any 2 sides of the triangle must be less than the third side. I want you people to write this down. It's very, very important. The sum of any 2 sides of the triangle must be greater than the third side, and the difference between any 2 sides of the triangle must be less than the third side. Very important. I think this is absolutely clear to each and every one of you. Let's take a small example. For example, I have not measured it, I have just drawn it as such, right? So let us suppose if any side is equals to 5 centimeter and any one of the side is equals to 12 centimeter. And if the third side in integral value, right? If any one side is 5 centimeter and any side is 12 centimeter, and if the third side is an integral number, we have been asked that how many possible values of x is there, right? Great. What we know? We know that the sum of any 2 sides of the triangle must be greater than the third side. Yes. That is 5 plus 12 must be greater than x, and similarly the difference between the two sides must be less than the third side. Very nice point. Very nice point. It means that 12 plus 7 is 17. 12 plus 5 is 17. This means that x must be less than 17, and 12 minus 5 is 7, and that is why x must be greater than 7. All in all, all the integral values which are between this are absolutely okay. Is it fine, everybody? Is it clear to all? What kind of values? 8, 9, 10, 11, 12, 12, 13, 14, 15 and 16. That's it. Is it fine, everybody? It's a very beautiful small point, but it's a very, very good point. If one of the side is 5 centimeter, another side is 12 centimeter, we know that the sum of any two sides of the triangle must be greater than the third side, and the difference between any two sides of the triangle must be less than the third side, right? So the third side, if it is an integral value, then it must be greater than 7 and it must be less than 17, and thus we can say that the total number of values here we can have are what? These are the values: 8, 9, 10, 11, 12, 13, 14, 15, 16. These are the values. And that is why I have given you a small question, and I want you people to solve this and post it in the comment box. I have given you a very beautiful question. What question is that? This one. I want you people to solve this and post this in the comment box. Right? This. It's a very nice, well crafted question. You need a small bit of geometry as well in this. The point I told, and this point which I told you just now, you need this point to solve this question. This will be your assignment question, so you can solve this and you can post the answer in the comment box. Is it fine, everybody? Is it clear to all? Is it clear to each and every one of you? Is it absolutely fine? Great, well done. So do solve this and do post this in the comment box, right? Great. So this is what today's class was. Is it absolutely clear whatever we have discussed in today's class? Great, well done. So we have precisely discussed probability in today's class, and I do believe that if you have understood permutation combination, this probability seems to be a cakewalk to you, right? It is actually very easy if you have a good knack on permutation combination. If you have understood permutation combination, then probability is very, very easy to all of you. Fine? Great. We won't be meeting in tomorrow's class. So tomorrow there won't be any general aptitude session. So we will not going to meet tomorrow. We'll straight away meet on Monday. Right? Do remember this. So on Sunday we don't have any class. Right? Right? So on Sunday we won't be having, I won't be taking any class. So on Sunday, that is tomorrow, I won't be taking a class from 2 to 4. Rather we'll meet on, straight away we'll meet on Monday. Right? Great. See you then. So we'll meet in the next class. Bye everybody. Take care. Jai Hind.